Greetings. Today me, Ravikesh Kumar, and Daniel Kazada are going to talk to you about what is energy.
Energy is defined as the ability to work, but it is also commonly referred to as the ability of a system to work. Fuck, let's restart.
Okay. Okay, wait, Daniel, I have another question. Are you going to say anything on this slide right here? Because this is supposed to be your slide.
No, I think we just it's just yeah, transition, yeah, that's the fucking sun.
Yeah. I'll just say, and and here's an example of what. No.
Yeah. Alright,
I just won't say anything.
I have 4%, let's go. Let's restart. Alright.
I just won't say anything on that slide. Okay. Ready?
Okay. Alright,
All
go.
right. Greetings. So today me, Ravikesh Kumar, and Daniel Kazada are going to talk to you about what is energy.
Energy is defined as the ability to do work, but it is also commonly referred to as the ability of a system to perform work. It is property. Fuck. It is a proper.
Okay,
Let's restart.
restart.
Okay.
Okay. Greetings. So today me, Ravikesh Kumar, and Daniel Kazada are going to talk to you about what is energy.
Energy is defined as the ability to work, but it is also commonly referred to as the ability of a system to perform work. It is a property that can be transferred from one object to another. It can also be converted into different types of energy. Other definitions of energy, depending on the context, such as thermal energy, radiant energy, electromagnetic energy, nuclear energy, etc., exist.
So what does energy look like? Common energy forms include the kinetic energy of a moving object, the potential energy stored by an object's position in a force field, such as gravitational, electric, or magnetic forces, and the elastic energy stored by stretching solid objects. Next, we have a few examples of what these forces would look like. Here we see kinetic energy. Here is an example of potential energy from gravity, but it also has kinetic energy since it's moving. Next, we have an example of elastic energy, since this is a spring.
Other forms of energy also include the chemical energy released when fuel burns, the radiant energy carried by light, and the thermal energy due to an object's temperature. Here we have some examples of this. Here we see coals burning, which is a fuel releasing chemical energy. Here we see light energy being released by this light bulb as radiant energy. And here we see thermal energy being released by this person's hands.
Energy can also be converted among itself. All of the many forms of energy can be converted into other kinds of energy. In physics, there is a law of conservation of energy, which states that energy can be neither created nor be destroyed. However, it could change from one form to another, such as potential energy gravity changing to kinetic energy.
So how is energy transformed? Well, some examples of energy being transformed include generating electrical energy from heat via the steam turbine of a nuclear power plant, or lifting an object against gravity using electrical energy driving a motor crane. Here we see the nuclear power plant that we mentioned earlier, converting energy.
So where does the energy on Earth come from? The energy on Earth mostly comes directly from the sun. The sun's light energy comes from electrons in atoms that lower their energy states and release energy. This energy in the atoms come from the nuclear reactions that happen in the heart of the sun. The sun transforms nuclear potential energy to other forms of energy. Its total mass does not decrease due to these energy conversions, since it still contains the same total energy even if it's in different forms. But its mass does decrease when the energy escapes out to its surroundings, usually as large emissions of radiant energy. Here we see a picture of what those emissions of radiant energy would be, also known as solar flares.
So how does energy apply in physics? Well, lifting gravity against gravity performs mechanical work on the object and stores gravitational potential energy in the object. If the object falls to the ground, gravity does mechanical work on the object, which transforms the potential energy in the gravitational field to the kinetic energy released as heat on impact with the ground.
In conclusion, this is how we would describe energy in application to physics. Thank you all for listening.